Greetings and welcome, friends. Today we are going to look at solving systems still, but some special cases that arise in them that we're going to see how to deal with those situations. We've talked about this before, the benefits of these different methods. Graphing, I'm never really a fan of, but sometimes it's good for visually understanding what's going on. Substitution is great when there's a weak spot. One of the variables has a coefficient of 1 or -1. And elimination is great when there are coefficients that are not 1 or -1, or if you just happen to have opposite coefficients for some of those things. So here are the special situations that we're going to talk about today. It turns out a system of equations, linear equations, can have one solution, which is every situation that you guys have seen so far, where we've described the intersection of the line as the x comma y combination that made both of the equations true at the same time, right? It turns out they can also have no solution, right? Pooja, if I asked you where do these lines intersect, you would say never. So this is no solution. Or if the lines are the same line, there are infinitely many solutions. Now, when I say infinitely many, that doesn't mean that every combination of x and y works. It means only the combinations that happen to be on this axis work, right? W, Z, or something like that, right? If I have a point over here, Q comma R, this point is not one of those infinitely many solutions, okay? So, yes, there are infinitely many solutions, but it does not mean that everything works. There's still particular values that will make it true. So let's look at what happens when I solve a system in which there's no solution. Okay, which method do you guys want to use to solve this one? Substitution, sure. So because step 1 in substitution is solve one of the equations for one of its variables, notice that both of these happen to be solved for y. So step 1 is done. Step 2 was, right, I could then take this and plug it in to the other equation for y. Yeah, remember that? It's been a few days since we've done substitution. So I'm going to have 2x plus 1 equals 2x minus 5. And let's solve this, right? Solve it. So let's get our x's together. Here we go. Subtract 2x from both sides. This sounds good. This sounds good. And guys, I got 1 equals -5. You'd have 6 equals 0 if you add 5 to both sides. The problem is my variables disappeared. And I was all like, what? And then I was left with a statement that if I asked my 5-year-old, is 1 equal to -5? He'd be like, no, that's ridiculous. Although I don't think I've talked to him about negative numbers yet. That's, man, what a privilege being a dad, being able to teach your kids about negative numbers. So anyways, this is not true. Do you guys agree? And because it's not true, all right, it's no solution. No solution, okay, is what ended up happening there. And so when your variables disappear, when sus variables disappear, and you end up with a false statement, there is no solution. Let me graph these for us real quick. Y equals 2x plus 1, y equals 2x minus 5. So if this has no solution, this is graphically what it looks like. Notice this. Those lines, they be parallel. I can look for love in all the wrong places, and I'm not going to find it here. Those lines have nothing in common, right? So, well, they have the same slope, I suppose, but they do not have any points that are in common, ever. So that's what a no solution situation looks like. Do you guys get that? You agree? Does that make sense? All right, let's look at a situation where we have infinitely many solutions. So here's example 2. Infinitely many solutions. All right. What's a good strategy to solve this one? Why? Yeah. What are you thinking? Where's the weak spot? Here's the weak spot. So step one, let's solve that equation for y. So negative 2x plus y equals 3. Also, just so you're aware, when it does come time for the test, you do need to know all three methods. So you can't just fall back on your favorite. So I'm going to, for some problems, I'll say solve by elimination. Others I'll say solve by substitution or graphing. No, for the test at the end of this chapter. Okay. So y equals 2x plus 3. If those things are truly equal, then that means I can substitute them for one another whenever I want. And so for substitution, I'm going to plug this in for y over here. And when we did substitution, we always had to plug it into the other equation. Do you guys remember that? That was the one time that it mattered, was in substitution. So I'll have negative 4x plus 2. Instead of y, I'm going to write this expression. Okay? So instead of y, I've now got 2x plus 3. I have to have parentheses here because I'm going to need to remember to distribute this too. Weep whoop pop. Weep whoop wop. But you guys are becoming experts at this. So proud of you guys. You're going to be my mathematical pack of ninjas. It's going to be awesome. 2 times 2x is 4x. 2 times 3 is 6 equals 6. Oh, combine like terms. This is great. I can bring these x's together. Notice I didn't have to add 4x because these were on the same side, right? They were both on the left side of the equal sign there. How many x's do I have? Oh, dear. We have... Guys, our x's all disappeared. I get... Well, negative 4x plus 4x. It's like I had a hole and I filled it in exactly right at... And then it's level ground now. Those canceled each other out. Those canceled each other. Yeah. And so I get 6 equals 6, which doesn't... That's not what x equals. All right, the x's disappeared. Is that a true statement or a false statement? That's true. 6 does equal 6. Man. Wow. So because this is true, that tells us there are infinitely many solutions. Okay, that's what that looks like. And even if I did elimination method for this problem, it actually would have had a similar outcome. Both of the variables would have been eliminated, and I would have had a true statement at the end telling me there's infinitely many solutions. And these solutions are limited to the solutions that make either of these equations true. All right, they happen to graphically... what's going on here? Let's see, negative 2x plus y equals 3. Let's write that equation. There's one equation. Let me delete this other one. Let's see what this one is. Negative 4x plus 2y. Negative 4x plus 2y equals 6. I think I made a mistake on this one. Yeah, this was a negative. So guys, watch what happens. Wait a minute. Guys, where's my intersection? Yeah. It's the same line. Well, so the intersections are all of the points. There's the y-axis right there. 3. Yeah. So yeah, all of these points are solutions, including that y-intercept. And all of these points make both equations true, right? And therefore all of them are solutions. But points like this, over 1 up 2, that is not a solution, right? So plugging in 1 for x and 2 for y will not work. Only the ones that are on that line will work. So that's what an infinitely many solution situation looks like. Let's have you guys try one before we do the word problem. Let's have you try monitoring progress, example 1. We'll have you guys try this. You can use elimination or substitution. I'll be around, walking around, helping out. All right, so looking at this, what was the preferred method of solving? What do you guys like? Oh, so you chose a elimination method? Now, substitution works great. You could have had, right, there's 2 weak spots here. But yeah, let's do elimination method. We haven't done that in a couple turns. 1 and 2, 2 goes, both of those go into 2. 1 and 2 here, both of these go into 2. What would I multiply this equation by to get a 2? Negative 2. Right? 1 times 2 is 2. 1 times negative 2 will be the opposite of it. So let's see. So if I'm doing elimination method, we would have had negative 2x minus 2y equals negative 6. And let's add these up. Right? So eliminated, and then, oh no, I accidentally eliminated everybody. Oh dear, oh no. Oh no, I didn't mean to. And I get 0 equals 0. Is that a true statement or a false statement? It's true, and therefore there are infinitely many solutions here. Right? Infinitely many solutions. Okay? If everything gets eliminated and it was a false statement, like 0 equals 1, then what would our answer have been? It would have been, well, yeah, it's a false outcome, and we would have said no solution. Question? Yeah. It wouldn't have necessarily come out with zeros. It might have been like 7 equals 7. But as long as it's true, yeah. Or no solution if you end up with a false statement. All right, let's do one word problem. Example 3. I don't know what you're asking. Oh, yeah. Oh, I see. Okay, yep. Okay, here we are. So, it says the perimeter of the trapezoidal, that's a good word, piece of land is 48 kilometers. The perimeter of the rectangular piece of land is 144. Write and solve a system of linear equations to find the values of x and y. Okay, so my variables, I don't really have, I don't know, x and y are just x and y. They're going to be measured in, actually, yeah, 2x is measured in kilometers. I don't know. It doesn't matter. We've got x and y. They're distance things. Here we go. Let's write equations, though. So, guys, how do I find perimeter? What does perimeter mean? And what do I do with the outside numbers? I add them. Perimeter is the total distance around a shape. So if I was to walk around this shape, that would be the perimeter. Perimeter is a linear distance. You would measure that in miles. If I was talking about area, that would be measured in like square miles, and that would be like, right, how many squares could I fit in there or whatever. So I'm going to say 2x plus, I'm actually going to write it this way, 4x plus 6y plus 6y is going to equal 48, is an equation related to that. Could someone help me write a perimeter equation for this one? Yep. So 9x plus 9x plus 8. Yep, that would work. Another way you could do it, and just because for variety I want to show it to you. We'll simplify. Yeah, that's a good point. The perimeter of a rectangle is twice the length plus twice the width. So that you could have had 9x plus 9x, or you could have just said 2 times 9x, and that'll actually be the same thing. I couldn't have done that on this one, other than for these two, I guess. So 2 times 9x plus 2 times 18y. So yeah, let's simplify these and solve this system. So for this top one up here, 2x and 4x is 6x. 6y plus 6y is how many y's? 12y equals 48. 2 times 9x is 18x. He's right. 2 times 18y is 36y equals 144. So, if I want to solve this, do you guys want to use substitution or elimination? Yeah, elimination. What do 6 and 18 both go into? 18. What do 12 and 36 both go into? 36. Let's deal with the 18. What could I multiply 6 by to get 18? 3. And I'll make it negative y. Yeah, so I'll have an opposite to the positive 18x, right? You with us, Cameron? So, let's multiply that through. So that's step 1 of elimination method. Negative 3 times 6x is negative 18x. Negative 3 times 12y is negative 36y equals negative 3 times 48. I've got a feeling is negative 144. Is it? It is. So when I add these together, what happens? I get 0 equals 0. So yeah, so that means there's infinitely many solutions. Well, yeah, that's a good question. Is there, now that we know this had infinitely many solutions, is there anything suspicious about those two equations that might have made me suspect there was going to be infinitely many solutions? Yeah, this is 3 times this one is equal to that one, or a third of this second one is the first one. Also, check this out. These two equations, the second one was just double the first. Up here, the second one was just double the first. Up here, how would I have suspected these had no solution? Think about y equals mx plus b. What were the slopes? They both had the same slope of 2, but if they had different y-intercepts, same slope is going to be parallel, different y-intercepts is different lines, and so those ones would have been parallel and not the same. So, let's see, infinitely many solutions. So how could I answer this question? Well, you could say, well, this equation is always true in this context. Oh yeah, for this problem, x and y have to be positive because I can't have a negative distance in the real world. But any combination of x and y that makes those equations true will work as long as they're positive. So yeah, the answer is as far as values of x and y that make this true, any positive values, I spelled that wrong, that make, let's just choose the simpler of the equation, 6x plus 12y equals 48 true will work. All right, so there's infinitely many solutions, but it's not everything. Right? It's so like there's infinitely many points on a coordinate plane, the x and y grid. A line doesn't cover the entire grid, but it still has infinitely many points. It's like that. Yeah, kind of weird. Well, anyways, thank you for watching, mis amigos de internet.